Picture this: a magnificent celestial body ablaze with energy, sitting at the center of our solar system. What comes to mind? That's right, it's our sun. This radiant enigma is a colossal sphere of hot plasma, fueled by nuclear fusion at its heart. It's over 100 times the diameter of Earth and makes up a staggering 99.86% of the total mass of our solar system. The sun is located approximately 93 million miles away from Earth, yet despite this vast distance, it's still the closest star to us. Its surface temperature is a scorching 5,500 degrees Celsius, which is so intense that it can take just 8 minutes and 20 seconds for its light to reach us. But the sun is more than just a giant glowing orb. It's a dynamic and ever-changing star. Its surface or photosphere is constantly in motion, creating a beautiful, though turbulent, dance of energy and light. This activity gives birth to some of the most mesmerizing phenomena in our solar system. Solar flares, for instance, are violent eruptions of energy that can release the equivalent of millions of hydrogen bombs in just a few minutes. Similarly, prominences are massive loops of gas that can protrude thousands of miles into space. These celestial fireworks, while beautiful, can also be disruptive. They can cause geomagnetic storms that interfere with our technology and even our climate. But they also provide us with a unique window into the workings of our sun and the fundamental processes that power our universe. The sun, a dynamic and ever-changing star, holds many secrets within its fiery heart. As we journey through this series, we will delve deeper into these mysteries, unraveling the complex processes that make our sun the radiant enigma that it is. At the heart of the sun, where temperatures rise to over 15 million degrees Celsius, hydrogen atoms are constantly fusing to form helium. This process, known as nuclear fusion, is the powerhouse of our sun and the source of the life-giving light that reaches our planet. Let's delve into what happens in this intense nuclear furnace. In the sun's core, under extreme temperatures and pressure, 4 hydrogen nuclei or protons come together in a series of reactions to form one helium nucleus. This helium nucleus is slightly lighter than the total mass of the 4 hydrogen nuclei that created it. It's here that Einstein's famous equation, E equals mc squared, comes into play. The m in this equation refers to the small amount of mass that's lost during the fusion process. This mass is converted into energy, E, at a scale dictated by c squared, the speed of light squared. The result? A tremendous amount of energy, equivalent to billions of nuclear bombs, is released every second. This energy gradually makes its way to the sun's surface and then radiates out into space as light and heat. It's this light that gives our planet its daytime brightness and warmth, fuels photosynthesis in plants, and powers our weather systems. But what about the sun's lifespan? Well, it's been burning for about 4.5 billion years, and it has enough hydrogen fuel in reserve to keep going for another 5 billion years or so. When it finally exhausts its hydrogen, it will start burning helium and evolve into a red giant, engulfing the inner planets, including Earth. But that's a story for another day. For now, we can take comfort in the fact that our sun will continue to shine brightly for billions of years to come, providing the energy that powers life on our planet. This fusion process, occurring billions of times every second, powers our sun and, by extension, our solar system. To bring us expert insights into the workings of our sun, we've invited distinguished solar physicists for a chat. Our first guest, a renowned solar physicist, shares, "Studying the sun isn't just about satisfying our cosmic curiosity, it's a necessity. Understanding space weather, which is largely driven by solar activity, is essential for predicting and mitigating its effects on our technology and environment. A sudden surge in solar activity, for instance, can disrupt satellite communications and even cause blackouts on Earth." Our second guest, another leading figure in the field, adds, "The sun's influence extends beyond space weather. It also plays a significant role in Earth's climate. Solar activity variations can cause subtle changes in Earth's climate. Phenomena like the auroras, those mesmerizing light shows in the polar skies, are also a direct result of solar activity. Charged particles from the sun interact with Earth's magnetic field, leading to these ethereal displays. While the sun's magnetic storms light up our skies with auroras, they also have the potential to disrupt our technological infrastructure. A particularly strong solar storm, our first expert cautions, could severely damage power grids and satellite systems, leading to widespread disruptions. This makes studying solar activity and predicting solar storms a matter of practical as well as scientific importance. Our second expert concurs, it's not just about understanding the sun for the sake of knowledge, it's about preparing ourselves for the future. As we become more dependent on technology, the need to understand and protect against solar storms becomes even more critical. The conversation with our solar physicists underscores the importance of the sun and its many effects on our planet. The sun, while sustaining life on Earth with its light and heat, also poses challenges that we must continue to study and understand. As our experts have shared, understanding the sun is crucial not just for our scientific curiosity, but also for our technological future. Peering into the fiery furnace of the sun requires some advanced technology. This celestial giant, a powerhouse of nuclear fusion, is not just observed with the naked eye. Instead, it's studied through a variety of sophisticated instruments and observatories, each capturing a different facet of this radiant enigma. Let's start with the ground-based telescopes. These are the traditional tools of astronomers. Equipped with solar filters, they allow us to gaze directly at the sun, observing sunspots, solar flares, and other surface phenomena. Observatories like the National Solar Observatory in the United States house some of the largest solar telescopes on Earth, providing unprecedented detail of the sun's surface features. But to truly understand the sun, we must step off our home planet. Space-based satellites offer an unobstructed view of the sun, free from the distortions of Earth's atmosphere. Among these, the Solar Dynamics Observatory, or SDO, stands out. Launched in 2010, the SDO has been continuously observing the sun for over a decade, capturing images in multiple wavelengths of light. This reveals the sun's outer atmosphere, the corona, and the violent eruptions of solar flares and coronal mass ejections. Then there's the Parker Solar Probe, a daring mission that takes us closer to the sun than any spacecraft before. It's helping us understand how the sun's corona gets so hot and what accelerates the solar wind and solar energetic particles. Together, these tools not only help us understand the sun's structure and behavior, but also protect our planet. They provide early warnings of solar storms that can disrupt our technology and power grids, giving us a chance to prepare and minimize the impact. With these instruments, scientists continually monitor the sun, providing us with invaluable data and images. As we uncover the sun's mysteries, we gain insights into our own planet's weather, climate, and even the mysteries of life itself. The sun's influence extends beyond the scientific. It has held a significant place in our cultures and histories. This fiery celestial body has been worshipped as a deity in many ancient cultures, from the Egyptians who revered Ra, the sun god, to the Aztecs, who paid homage to Huitzilopochtli, their sun and warfare god. In ancient Chinese mythology, it was believed that a solar eclipse occurred when a celestial dragon devoured the sun. Such historical events sparked fear and awe, leading to rituals to ward off this perceived threat. In more recent times, the sun continues to inspire art, literature, and music, reflecting its enduring cultural significance. It's a symbol of life, growth, and energy, central to our daily rhythms and seasonal patterns. Yet it's not just about symbolism. The sun's influence is tangible. It drives agriculture, weather, and even our body's vitamin D production. From awe to fear, the sun has always captivated the human imagination. As we continue to explore the cosmos, the sun remains a source of fascination and mystery. This radiant enigma, our very own star, is a dynamic entity, continually changing and providing us with a spectacle of solar flares and prominences. It's a nuclear furnace at its core where hydrogen atoms fuse into helium, releasing vast amounts of energy that fuel life on Earth. The sun, essential for understanding space weather, influences our climate, shapes the auroras, and even disrupts our technology. The tools of scientists, from ground-based telescopes to space-based satellites, are ever trained on its fiery surface, seeking to decipher its secrets. Throughout history, civilizations have both revered and feared the sun, celebrating its life-giving warmth and fearing its occasional eclipses. It's a profound reminder of the sun's influence over our solar system and the importance of our ongoing quest to unravel its mysteries. In understanding the sun, we take a step closer to understanding our place in the cosmos.